Even though the James Webb Telescope has only been in use for 2 years, it has already created quite a stir in the field of astronomical research. However, how can we explain the early galaxies that Webb discovered which completely contradict our current theories? What about the perplexing deviation in the cosmic expansion rate that has always left researchers perplexed? Who knows? Perhaps these impossible discoveries are the result of merging with other universes, because what initially seems like the plot of a ridiculous science fiction film is actually the central idea of a recently published official scientific study that could lead us directly to an amazing discovery. While the inhabitants of the past primarily referred to divine creators in this regard, modern scientists take a slightly different approach by observing other galaxies and measuring distances. The sight of the starry sky at night is simply overwhelming. But it also raises a straightforward but profound question: where does it all come from? In other words, how did the universe with its enormous diversity come into being in the first place? In recent decades, scientists have created a definitive picture of the universe's birth and development. According to the standard model of cosmology, it all started about 13.8 billion years ago, when space, time, and matter emerged from an unthinkably dense and hot singularity. However, the Big Bang not only cleared the path for the universe's unfolding, it also started a process that is still going on today. Cosmic expansion is used to explain the observed accelerated. The universe's expansion, the mysterious dark energy, has again been invoked, although its existence has not been directly proven experimentally, and its physical interpretation is largely unexplained. And yet our understanding of the universe today is more precise and comprehensive than ever before. But what if this is simply not true? What if our basic cosmological assumptions are simply no longer tenable due to new discoveries? Well, this is precisely the question that astronomers are inevitably confronted with at the moment, because, as you have probably noticed, the James Webb Telescope has already detected several structures that, according to our theories, should not exist. In this format, all this applies in particular to the impossible galaxies, which were already formed in the early days of the universe and throw our models into chaos with their astonishingly large masses in detail. Webb has identified 6 galactic precursors whose light took more than 13 billion years to reach our terrestrial eye, and which, despite all this, were already almost as developed as our Milky Way today, since, and according to our understanding, there was simply not enough normal matter to form such massive association. So soon after the Big Bang, this unexpected discovery calls into question our entire picture of early galaxy formation, and the subsequent discovery shows that this is by no means a confusing, isolated case. With Z140, Webb added another early galaxy to the star charts that existed as long as 290 million years after the Big Bang. However, the Space Telescope not only provided experts with a new record-breaking galaxy, but also another agonizing puzzle. In light of this, the common perception of an early cosmos that only contains small, faint galaxies appears to be out of date. However, the most powerful space telescope ever has confirmed a number of unexplained discrepancies in the Hubble constant that have been plaguing scientists for years. The experts' analysis revealed that Z140 must have already contained several 100 million solar masses of stars. Additionally, the presence of oxygen in the emission lines suggests that several generations of very massive stars must have completed their life cycle before the researchers observed the galaxy. Adam Rees is the one who knows the most about the expansion of the universe. After all, the US astrophysicist shared the 2011 Nobel Prize in Physics with Saul Perlmutter and Brian P. Schmidt for discovering accelerated expansion. However, the renowned expert can be quoted as follows about his most recent research series: "There is a real and exciting possibility that we have misunderstood the universe, and in order to understand what this profound statement is all about, we must keep in mind that, contrary to all expectations, the expansion of the universe is not uniform everywhere. In fact, it appears to be expanding more quickly in our cosmic neighborhood than in other parts of space, which is obviously not the case. Dark energy, which is meant to oppose the gravitational pole, is the driving force behind the universe's fast expansion. The Hubble constant, a component in Einstein's field equations that characterizes the rate of expansion, in turn indicates how quickly the universe is now expanding. Adam Rees explains that he and his colleagues can predict this expansion rate by measuring the cosmic background radiation and then using the theoretical models of cosmic development to determine the current expansion rate. This results in a Hubble constant of 67 kilometers per megapark, as at the same time. However, it becomes extremely confusing at this point. If we now use a different measurement method, the value for the Hubble constant is suddenly completely different. In other words, if we determine the Hubble constant on the basis of supernovae red giants' gravitational lines and variable stars or so-called sides, we arrive at a result of 73 kilometers per second per megapark. In other words, the universe is expanding faster than it should be. But how is this even possible? Well, the simplest explanation is based on the assumption that the discrepancies result from a combination of measurement errors and inaccuracies. And to check exactly this, the team around Rees used Webb's near-infrared camera NIRCam, which then took a close look at over 320 SIDs in several galaxies, as many of these stars had already been targeted by the Hubble Space Telescope. A comparison was made possible by the re-examination, which finally showed that the Hubble data was accurate. In other words, Adam Rees, the Nobel Prize winner, suggests that there may be a process or a force behind the faster expansion of the cosmos that has not yet been taken into account in the standard cosmological model. This could be an exotic form of dark energy or dark matter, or our understanding of gravity may be flawed, or there may be novel particles or fields out there that are completely unknown to us. This means that the new Webb data sets also yield a Hubble constant that clearly exceeds that from the theoretical models. But why is that the case? Ultimately, the Hubble discrepancy can be explained by a variety of theories. For instance, the so-called intelligent design movement contends that certain aspects of the universe are best explained by an intelligent cause, because the universe's fine-tuning contains obvious signs of a conscious blueprint. This group of scientists is therefore open to the possibility of a creator, but it is not specifically defined as the scientific investigation of the thesis that the cosmos's complexity and order point to a superordinate design and plan. An additional theory that was published in the Journal of Cosmology and Astrophysics Physics is both exciting and unconventional. The deviation of the Hubble constant may be due to the merging of our universe with other universes. This approach departs from the notion of the menacing dark energy, which on paper could theoretically accelerate the expansion of the universe, but whose existence has not been established, and where the fusion of cosmic worlds is thought to be more likely. Jan Ambjorn, a physicist at the University of Copenhagen, notes that the fusion model with so-called baby universes may be able to explain the data even more well than the conventional cosmological model. In order to study the potential effects of multiple interacting universes on our cosmic home, the study's lead author and his team created a mathematical model. Their calculations revealed that merging with other universes should increase the volume of our cosmos, which could be interpreted by our measuring devices as an expansion of space. Concurrently, the scientists calculated the rate of expansion of the universe that would occur in such a scenario, and they discovered that the calculations based on cosmic unification were even more consistent with observations of the universe than the conventional standard cosmological model. Furthermore, the new theory addresses the issue of cosmological inflation, which is the incredibly fast expansion of the cosmos thought to have occurred soon after the Big Bang and continues to this day. Physicists have suggested that the rapid expansion was caused by the inflator hypothetical field that drove the ultra-fast expansion in the first milliseconds after the Big Bang. However, the authors of the new study now explain cosmological inflation by saying that our young universe may have been absorbed by a larger parent universe, and if you like our world, then followed in its mother's footsteps. The scientists suspect that our universe continued to collide with other baby universes after its absorption and swallowed them up too. But how could this exciting theory be tested? Might it even be possible to catch a direct glimpse of the baby universes that our ever-growing world is currently absorbing? While not quite the main focus of the experts, is currently on microwave background radiation. This almost isotropic radiation, which fills the entire universe and was created shortly after the Big Bang, could therefore have some unexplored properties that may lead us to a groundbreaking discovery in the near future, and we would be delighted. If your near future leads you to the subscribe button, now feel free to press the thumbs up and subscribe to never miss another exciting video from us.